Hello everyone. Today we are going to discuss about smartphone addiction detection prediction. So here what we are doing is we are trying to detect if the person is addicted to their smartphone or not based on their data. The data that we are using to predict their addiction is their age, gender, location, phone brand, OS, screen time, amount of data used per month, and calls duration, that is minutes per day, and number of apps installed, how much of the time they are spending on social media, how much they are spending on online, and how much of the time they are spending streaming per day, and how much they are spending gaming per day, and how much is their monthly recharge cost, and what is the primary use of their phone. So these are the things that we are taking as our data, and based on these things we are going to predict if the person is addicted to their phone or not. Now you can see here we don't clearly have a target variable. We have the data set, and this data set is really good. I mean, the data set encompasses a lot of things, and it is a very viable data set for a project like this. So we are going to spend good amount of time in creating our own target variable and also some of the other things in the data as well. So the first, let's look our data. This is our import toolbox. Okay, so here we are importing all our required libraries. First is we are loading pandas. Import pandas as PD. This is used for tables like Excel in Python, because Python loads the pandas module into memory, and without pandas you'd have to manually manage lists, which is a nightmare for machine learning. Then next comes NumPy, which is a numerical engine which is used to handle all the arrays. Then Matplotlib and Seaborn is for visualizations. Next, in the next part, we are loading the data set. So till here we are importing all the required libraries. Then here we are loading our data. Our data is in CSV format. So this file is parsed line by line, and then it is converted to tabular structure. So this entire data set is right now present in your RAM. Now df.head 10, this is showing your first 10 rows. Then df.info, it is showing the column types, missing values, the amount of memory it is using. It is going to show all of those things. Then next line, df.isNull.sum, it is going to count missing values per column. Then df.describe, it is going to give you statistical summary, that is mean, standard deviation, minimum value and maximum values. Then comes in feature engineering. Here we are converting the minutes into hours because our calls duration are in minutes, but the rest of the columns have in hours. So what we are doing, we are converting this into number of hours per day. Then next we are calculating total screen time. So if you sum the time of social media, gaming, streaming and call duration, then it is going to give you screen time, that is how much of the time they have spent looking at their screen. Then we are performing a little bit of data cleaning check. That is, if you have looked at the data set, even at the brand Apple, there is iOS, and even where there is a brand like Realme or something like that, the OS is iOS. We have to filter such inconsistent rows. So the iOS should only be for Apple. Then we are creating age groups. That is, we are converting our ages, which is our continuous data, into categorical data, into teen, adult, and senior. Internally, we will check which if the value falls into which bin, and then a label is assigned to it. Then we are dropping user ID column because it is not useful. See, those are personal identification indicators, and identification indicators are not at all useful anywhere in machine learning. Then label encoding. All the categorical columns. See, usually machine learning models need numbers, but there is text as well in our data. So now to convert those text into numbers, we are using label encoders. So this line categorical columns select D types, include objects. This is going to find all the text columns. Then it is going to go through each column and convert that column into label encoded column, and then it will get it. This will again add it to label encoders dictionary that we have created here. Then comes risk engineering, which is a smart feature design. Here what is happening is we are converting the number of hours into the risk levels 1 to 4. Okay, based on the number of hours. See, 0 to 6 will come, 0 to 5 will come under one risk. Then 6 to 12 will come under one risk. In the same manner, we are converting everything into labels. Same for screen risk, social risk, because instead of just raw numbers, here we are giving risks that is going to create a better discretized data for you. Then at the end, what we are having is addiction score. I told you, right? We don't have a specific target variable till now. Now, because of these risk values, because of the risk labels, we can now get the addiction risk score. We risk all of the risk factors, and then based on the numbers that we get as an output, we are again classifying that into low, moderate, and high. Till now, we did not have any target variable. Now we have our own target variable or label. This is how we have created our own target variable from the data that we have using feature engineering. Then we are performing feature selections. Other than these features, we have created some other features as well in the part of feature engineering, and most of them are not much useful. So how do I know that? You have to perform a little bit of domain research, only then you will get to understand that. Then we have separated them into training variables and our target variable. Fine. Then we have performed train test split. So the main thing of train test split is if you train your model on 100% of the data, then you won't have any data left for testing your model performance. So what we do is we keep a part of the data aside for testing the model performance. That is what train test split is entirely all about. Then scaling. Here what is happening is internally some models need normalized data. Normalized data in the sense each number will be in different scale. Now the age of the person will be in different scale and the number of hours will be in different scale. Amount recharge will be on a different scale. Yes. So now to bring all of them into a similar scale, we perform normalization. So that normalization is being performed here using standard scalar. Then we are using models to train. We are training on various models. Here you see we are training using logistic regression. Then we are checking the accuracy of it. Then again we are training on random forest classifier. We are checking its accuracy. We are training on XGBoost. We are checking its accuracy. Then we are training on support vector machine. We are checking its accuracy. Then whoever is best, we will save the model using these lines of code. You can see here from import pickle to pickle.dump. Using these lines of code, we save our final model. So till now, this is how we have built our model. Then next comes Streamlit deployment. Now here you can see Streamlit is a Python library that is used to build user interfaces, and this is a very stably used library in data science world. So here you're just creating a page configuration, that is you are just adding a little bit of metadata for your page. And here using st.cache resource, we are loading our model. Then we are giving all the user interface and user experience things, that is we are setting a title and then we are using a subheader. Then here what we're doing is we are taking inputs. You can see st.number input, voila, it takes inputs. In the same way, we are taking all the 5 inputs that we need. Then we are performing all the feature engineering and all the feature classifications, conversions, whatever we have did in our model building, we are doing all of those things again, because the input that you have model gotten, it will be in normalized format and it will be in a scale format, right? And also the conversion will also be done, the unit conversions, all of these have been done. So if you do not provide in the same format as your model training input format, then you will not get predictions, you will get errors. So we have to repeat all of those things here again. Then based on that, it will provide you the output: low addiction, moderate addiction, high addiction. This is how the Streamlit deployment code is written. Now, once you get your hands on this code, what you have to do is you have to open a Git Bash terminal. After opening a Git Bash terminal, you have to create a virtual environment, python-m venv.venv. Using this line of code, you can create a virtual environment. After creating virtual environment, you have to activate that virtual environment using this lines of code. Using this line of code, you activate your virtual environment. After that, what you can do is you have to install the requirements -r requirements.txt. You install all your requirements. Now requirements.txt is present here. So whatever is present inside this file will be installed in your virtual environment. After it is successfully installed, you say streamlit run app.py, because all your Streamlit code is written inside the app.py. So this is Streamlit run app.py. Now, once the execution is done, you see logs like these, and also you see an URL. If you click on this, hold Control and click on this will open in a new browser page, and you can see your deployments over there. I hope this explanation was clear. See, once you are done, if you want to kill this, you say Control+C inside this terminal and it will stop everything. Stop your Streamlit deployments. So I hope this was informative enough, and I hope you got to learn something from this session. Thank you for your time, and I'll see you in the next one.